All right, all we have to do today is go over the homework because this is the last section of this chapter. In fact, this is the last section of the year.
You don't have like a hard lecture.
Sure.
Yeah, isn't there something like hard, or you said the next class is gonna be hard?
Yeah, we did it already.
Huh.
We did it last time. Okay, what problems do we need to go over? Go.
41 to 47.
41
Odd.
to 47 odd. That's a dollar. What else? 39. 59. 51. 53. 55. Isn't this like everything? What was the assignment? The assignment was 33 to 59 odd. Oh, so you guys could do the beginning ones then.
Yeah.
Okay. Okay, so 33, all you had to do was multiply and divide. So that was easy enough. Except 39, oh, come on! Okay, see, they make one problem a little bit different, and you guys are all thrown off. And it says, leave your answers in polar form. Okay, so what you want to do here, see, like all the other ones, they gave you the complex numbers in polar form. Now you have to put it in polar form. So, both of these, you need to change it to polar form. How do you do that? What's the fastest way to go from standard to polar form? It wasn't that long ago we had class people. Draw the picture. So like this first one. If I go 2 to the right and 2 up, 2 to the right and 2 up, how far from there again am I?
You are 4.
2, who said 4?
2.
2 root 2.
I know.
How can it be 4?
I'm thinking the other triangle. Sorry.
No, the other one is 2. And then, what is this angle, since it's a 45, 90 triangle? That's 45 degrees. That's why you don't mess with the formulas, you just draw the picture. And then what about this one? If I go root 3 to the right and 1 down, so root 3 to the right and 1 down, how far from Oregon am I? 2. See, because, look, in a 45, 90 triangle, see how these two things are equal? The hypotenuse is just radical 2 times the leg. In a 30, 60, 90 triangle, see how you get the radical 3? One leg is going to be radical 3 times the other, and the hypotenuse is going to be double the short leg, right? We learned all of this in geometry. Now, this is a 30-degree angle, so what do you want to write? You want to write, okay, so this is 2. Do you want to go like this and go, rah, 330 degrees? Or do you want to just go negative 30 degrees? Just go 30 degrees clockwise. It's up to you.
Bruh.
No, what do you think? What do you think you're going to do on the test? What do you think you're going to do?
You're bruh.
Negative 30? You guys rather go negative 30?
Yeah.
Or 330? You sure? You sure? It's way easier if it's negative 30, you know. Okay, because look, the first thing they want you to do is multiply the complex number. So when you multiply these two, you multiply the r's. What is 2 root 2 times 2? Are you serious? 4 root 2, kiss, and what do you do with the angles? You add them, and then look how easy, that's 15 degrees. Whereas, if this was 330, you have to add 445 plus 330, 375, and then you gotta reduce it down. Yeah. I think negative 30 is better. And then you have to divide the complex numbers, like this. So, what is 2 root 2 divided by 2?
Root 2.
The 2's cancel out and you get
Root 2.
root 2, kiss, and then you subtract the angles. What is 45 minus negative 30? You gotta be kidding me.
75.
75 degrees. Whereas, if you had 330 there, what is 45 minus 330? Negative 285, and then you gotta add 360 to it. It's better to be negative. And the reason why is because, look, just in magnitude, isn't 30 just small, way smaller than 330? It's just easier to work with. Okay, so that problem was the same as all the other problems. You just have to do the extra step of changing it into polar form. By now, we should be experts, right? Okay, 40. No! No! Okay, 41. Okay, now remember, okay, the way the book writes it 40, and they write it all out, but remember, just write it like this, 4, kiss, 40 degrees, just write it like that. Okay, now what they want you to do is raise it to the third power. Anyway, that's the way I'm gonna write it. So, how do you raise a complex number to a power? What theorem are we gonna use? What is it called again? We're not going anywhere until we come up with the theorem.
Was.
There you go, thank you. De Moivre's theorem. How do you guys forget that?
Oh, very weird word.
Okay, so to raise a complex number to a power, all you have to do is go r to the power. What is 4 to the third? 64. And then what do I do with the angle and the power? You multiply them together. 40 times 3 is 120. Finished. Except the directions in the book says to leave it in standard form. So now we gotta change it back. But that's easy because what is KISS an abbreviation for? Cosine theta plus I sine theta. See, these problems are easy because you just leave it in polar form because that was the directions, yeah? Okay, but if you have to change it back to standard form, this is what you gotta do. And then you just gotta know your trig values. Cosine of 120. Ignacio.
It's half. Yeah. Right?
Except, look, you went sharp. That's to the left.
Oh, negative half.
Negative half. And then sine of 120. Noah?
Sine of 120 is root 3 over 2.
Root 3 over 2i. Distributize the 64. Negative 32 plus 32 root 32 root 3i. Look, De Moivre's theorem, that's like the easiest of the theorems. You just raise r to the power and you multiply the angle times the power. That's so fast. Okay, now we're doing 43 now. 43. Okay, what do we got? We got 2 kiss pi over 10. And we're gonna raise it to the 5th power. Okay, so how do I do that? 2 to the 5th is 32. And what do I do with the angle and the power? You multiply them. What is pi over 10 times 5? Pi over 2. Look at this, it's so fast. And then now they want you to change it back. So now, KISS is an abbreviation for cosine theta plus I sine theta. Correct? And then now you just gotta know your trig values. Cosine of pi over 2, I know we know. 0 plus sine of pi over 2, Arita?
Root over 2.
No!
Well, no, it is.
No! If it was, then I would
Power
be
is
told.
90 is 1.
Okay, 1 I, and then if you distribute the 32, you get 0 plus 32i, but we just write 32i. So it seems like the hardest part of this is you guys forgot your trig values. Or you're not quick, like you guys. Remember before, you guys used to be quick as cats before? I think you were. Maybe we need more speed quizzes. Okay, do I have to continue this charade? 45, who asked for this? Noah? Root 3, kiss, 10 degrees, raised to the 6th power. Okay, look, we're doing the same thing every single problem before. What is root 3 to the 6th power? Garcia, read it off the paper. Root 3 to the 6th power. Wow, you sound like your voice came from there. That's amazing. Okay, radical 3 is like 3 to the half. If you raise it to the 6th power, what do I do with the exponents? Rhymes with multiply. You multiply the exponents, so you get 3 to the 3rd, which is 27, kiss, and you multiply the angle times the power, which is 60 degrees. Look, you're done. That's the answer. All you gotta do is change it. So kiss stands for cosine 60 plus I sine 60. Okay, now we just gotta know our trig values. Galaccio, cosine 60.
Wow.
Gemello, sine 60. Root 3. See? Look, we're like lightning. Distribute the 27. So 27 over 2 plus 20. What is this crinkling? Okay, and then 47. Are we making headway? Okay, what is 47? 47, we got radical 5, kiss 3 pi over 16. Uh-oh, I sense, oh no, this is gonna be nice. Okay, so to raise it to the 4th power, you gotta go radical 5 to the 4th. Arakawa. 25, kiss, and you multiply the angle times that, so that's 3 pi over 4, right? Oh, nice angles. And then now you just gotta go. Now after a while, you don't even have to write that, you just know already, right? You know what kiss stands for. You don't have to do this. But I guess if you're in the embryo stage and you need it, yeah? Okay, so now you just gotta know your trig values. Cosine 3 pi over 4. Yo! Drawing pictures all over our hands. That's what we do in class.
Yeah.
Where's the homework?
I was on my iPad and I forgot it at home again.
So then draw pictures on your hands.
Yeah, I'm sorry.
What is going on here? Yo! Post.
Root 2 over 2.
Except it's,
Negative.
yeah, negative root 2 over 2. Just for that, Ignacio, sine 3 pi over 4.
3 pi over 4, it's like... Okay, it's root, no, it's root 2 over, root 2 over 2. Yeah.
And then if you distribute the 25, you get negative 25 root 2 over 2 plus 25 root 2 over 2i. There you go. Okay, that takes care of all the Demon's theorems one. And then the last part of the thing is the complex roots theorem. So 53. How come nobody asked 51? 51 is probably the hardest of them all. 51. Yeah, but then I wrote it and then you said cross off 51, remember?
I said cross off 59, you cross off
I crossed off the one. Yeah, whatever. 51. Radical 2 minus I to the 6. So it looks like we're going to have to use a calculator for this one. That's what it looks like to me. Okay. So, see, like all the other problems, it was in polar form already, but it's not in polar form. So you have to change this to polar form. That's what makes the problem tougher. So what's the fastest way to go from standard to polar? Draw the picture. If I go radical 2 to the right and 1 down, like that, how far from Oregon am I? What? Yeah, that's like 1i, right? Radical 3. Using the Pythagorean theorem, so radical 3. Now, what is this angle right here? Is that an angle we know? No, so you gotta use your calculator, right? So cos theta, tangent theta is equal to opposite over adjacent, 1 over root 2. So to figure out this angle, you gotta go tan inverse on your calculator. Huh? Theta is equal to tan inverse 1 over root 2. Okay, do I need to get my calculator? Since I don't see people reaching. Okay, I'll get it. Okay, so shall we do degree mode? Okay, I take that for a yes then. Put this in degree mode. And so tan inverse 1 divided by the square root of 2. Shoo! Woo! So theta is equal to 35.264386968 degrees. That's what this angle is here. Well, what angle do I put here? Remember, angles are always measured from the positive x, so you either gotta go like this, all the way around like that, or do you wanna just go negative that? Yeah, negative. So why don't we put negative 35 point, we need more. 264386968 degrees. And then, now we gotta raise it to the 6th power. So let's do the easy part first. What is radical 3 to the 6th power? Yeah, we did that before, I had 27. Kiss, and then now you have to multiply this times 6. Now, but I have that on my screen. So I just times it by 6, you don't have to store. Times 6. So this comes out to negative 211.5863381 degrees. See how I'm using all the decimal places? And then again, what does KISS stand for? Cosine theta, which is negative 211.5863381 degrees, plus I sine negative 211.5863381 degrees. So since we're going to have to compute the sine and the cosine of that angle, you know what you might want to do? Store it. So I'm going to store it in A. Okay, so this is A. So that way when you punch it in on your calculator, you just have to go cosine A. So what you have to do now is you have to find the cosine of this angle, and then you got to distribute the 27. So you must as well do it all at once. So cosine of A, like that, and then times 27, I get, oh, it comes out nice, negative 23. Wow, now I'm thinking maybe we didn't need to use the calculator. Yeah, we didn't need a calculator. But we did it already, eh? And then, take the sine of this angle, and distribute the 27. So, sine of this ugly angle, which is apparently not that ugly, times it by 27, and I get, plus, oh, this one comes out a little bit more ugly, 14.142, and then the I always goes on the second one. Okay, you don't need to worry, because on the test, there's no calculator, so you're not going to get this problem. It'll be like all nice angles that you're supposed to. Yeah. Okay, so that was the last of the Mom's theorem. So the last part of the homework is the complex roots theorem. So pretty much, am I doing every single problem? That's what I'm doing, isn't it? I'm doing every single problem.
No.
That's okay, I don't mind. You know why? Because then it's on video. Okay, so what's next? 53, 55, 57, 59. How come there's no... That's so strange. You guys can do 57, but you can't do 53, 55, and 59. You know what? I'll just do them all. 53. Okay, now, the way they say it in the book, it says, find the complex cube roots of 1 plus I. That's the same thing as solving this equation. You guys understand that? Because look, okay, let's go back to algebra 2. If you have this equation, x cubed equals 8, what does that mean? You're trying to find the cube roots of 8, right? So if they ask you to find the cube roots of 1 plus I, that's the same equation here. What number cube will give you 1 plus I? Let me make sure I copied it down correctly. Yeah. Okay, so here we go. Before we even start, how many answers are there going to be? 3. Okay, there's going to be 3 answers. Because every single year, there's always students only giving 1 answer. If you only give me 1 answer, you're only going to get like 1/3 of the points now. In fact, I'm probably going to give you less. So the first step is to change this into polar form. the simplest way is to draw the picture. Okay? It's not x and y, fool, it's real and imaginary. If I go one to the right and one up, one to the right and one up, how far from origin am I? Radical 2, that's r. And then what's that angle there? Just look at the picture. What's that angle? 45 degrees, right? Or if you want radians, put pi over 4. I don't care, radians or degrees. Now, did you guys, as you did the homework, did you figure out how the complex roots theorem works? Homework? Some of you go, homework? It was homework? Okay, let me write this down. Let's identify all the things again. This is n. Some of you forgot. This is r. This is theta. You just plug it into the complex roots theorem, the one I wrote on the board, or the one that's printed in your book, right? So, to solve for z, it's the nth root of r. Oh my goodness. So it's going to be the cube root of the square root of 2. Wow, that's something. Kiss theta plus 2k pi if you're in radians, but if you're in degrees, what? 360k all over n, where k is equal to 0, 1, and when do I stop? 2. Because remember, you stop at n minus 1, so if n is 3, you stop at 2. I forgot this is 3. Okay, now, what is the cube root of the square root of 2? Okay, let's go back to algebra 2. What is square root of 2? Isn't that like 2 to the half power? And then when you cube root it, isn't that like to the 1/3 power? What do you do with the exponents in that case? You add them or multiply them? You multiply that. So this is the same thing as 2 to the 1/6 power, or the 6th root of 2. Now, to get the first answer, you're going to plug in 0 for k here, right? What is 360 times 0? 0 plus 45 divided by 3? 15 degrees. That's the first answer. Now, remember last time you guys had problems plugging in 1 and 2, so what was the shortcut I taught you? They're all going to be equally spaced apart. So, if you have 3 answers and they're equally spaced apart, just divide 3 into 360 and you get 120. So, that means all the angles are going to be 120 degrees apart. So, once you find the first answer, the second answer, you simply just add 120 to that. 135. To get the third answer, you just add another 120 to that. So it's going to be, what's that? 255? There you go. Those are your 3 answers. And do they want you to change it back? It says leave your answers in polar form, so just leave it like that, and the argument in degrees. See, they don't even want radians. Okay, let's just do a couple more, and then you can see how it works. See, because you can really do this really quickly if you know what you're doing, you know. Okay, 55. It says find the 4th roots of that. So, in other words, what complex number to the 4th power will give you this thing here? What's the first thing I need to do? Change it to polar form. So we need to change this to polar form. Okay, what's the fastest way? Draw the picture. Okay, if I go 4 to the right, like that, and then 4 radical 3 down, like that. Notice how 4 radical 3 is bigger than 4, that's why I made it longer. How far from origin am I? People, when you got the radical 3, that's a 30, 60, 90. The hypotenuse is double the short leg. So that's the short leg, just double it. It's 8. Kiss, and then what's that angle there? Is that the 30 or the 60 angle? That's the 60. So what do you want to do? You want to go all the way around and go 300? Or would you rather just go negative 60? Which one would you rather do? Okay, that's up to you. It really doesn't matter, that's why. Okay, so, I'm not going to write this theorem down, okay, I'm just going to just show you the short way, it's easier. So, how many answers are there going to be? 4, so if you have 360 divided by 4, you get 90. every answer is gonna be 90 degrees apart. So once we find the first one, we just keep adding 90 every time. So z equals the fourth, see, if it's to the fourth power, you're gonna take the fourth root of that number there. Just like over here, we're trying to find 3 answers, it's gonna be the cube root of that number there. So what is the fourth root of 8? What is the fourth root of 8? How do you want to write that? Should we just write fourth root of 8? Is that acceptable? You know what? I'll just accept it. Okay, kids, now notice what happens. When you plug in 0 for k, this thing just becomes 0. So basically, you're just dividing that angle by n, which in this case was 3, right? So, what am I going to do? What is n in this problem? 4. You just basically divide that angle by 4. That's what you're doing. What is negative 60 divided by 4? Negative 15 degrees. That's the first answer. That's how it works. That way you don't have to like memorize. Some of you are probably worried about the test. Mr. Park, how am I gonna memorize this formula? You really don't need it. Okay, what's the next answer? I just told you how to get the next answer. What do? You keep on adding 90 degrees. So what's negative 15 plus 90 degrees? What? Okay, I'll do it for you. 75 degrees. What's the next answer going to be? It's going to be the same thing except you add 90 degrees. Okay, if you cannot add 90, I'm sorry. And then, what, you just want me to just write down the answers? That's shameless. That's so shameless. Okay, let's even write that down since we're doing them all. Now, hey, Mr. Park, this complex roots theorem is kind of like the reverse of de Moivre's theorem, right? Because de Moivre's theorem, you raise r to the power and you multiply the angle times the power. So in this one, you're taking, since you're going backwards, you're taking the fourth root of that and you're dividing the angle by 4. So it's the reverse of de Moivre's theorem. Did anybody even notice that? Galaccio? No. Pan? Yamashita? Chi? Okay, just keep avoiding eye contact, Yamashita. 57! It worked all semester, Mr. Park. Find the fourth roots of 69. So what number to the fourth power is equal to negative 69? That's what we're doing. Don't worry, this is the way I'm going to write it on the test. Okay, so the first thing you want to do, and what you should do is put the 0 there. 0 minus 69 because it's easier, okay? Write this in polar form. So draw the picture. If I plot the point 0, negative 16, so 0, negative 16, like this. Here's the point 0, negative 16. How far from the origin am I? 16. What's this angle like that? 270, or would you rather go negative 90? This time, let's just go 270. Let's do something different, okay? Okay, so how many answers are there going to be? It's fourth power? Fourth root?
4.
4 answers, okay? So 360 divided by 4 is 90. So every 90 degrees, you're going to have one. So if I could just find the first one, I just keep adding 90 every time. So what do? You take the fourth root of 16. Can we do that? 2. And then you divide that angle by 4. What is 270 divided by 4? Whose turn is it? Numa. 270 divided by 4. And don't say 270 over 4.
I'm not good at this. I have to write this down.
Okay, write it down then. 270 over 4. Divide top and bottom by 2.
67.5.
There you go, 67.5. I can't believe that's the hardest part of the problem. Okay, and then how do I get the other 3 answers, Mr. Parks? What do I do? You just keep adding 90 degrees because they're all equally spaced apart. So once you get the first one, add 90, go. I'm gonna carry Mr. Park, I can't do it. 157.5 add 90. 247.5, add another 90. 337.5 degrees. How come we cannot add 90? So you want me to make it just come out to like 30 degrees then? So you're telling me you don't want fractions? Is that it? Okay, nobody wants, okay, I'm gonna make bizarre fractions just for that. Okay, you guys want fraction. We like the challenge, Monsieur Park. And then 59. Okay, this is the last one. 59. The complex fifth roots of I, which is the same thing as solving this equation. Z to the fifth is equal to I. See, if I were making this problem, I'd put 32I. Because then fifth root of 30, because you don't want a fifth root 1, right? Fifth root of 1 is too easy. Fifth root of 32, that's more interesting. Anyway, so this is like 0 plus I, right? We need to change this into polar form, so draw the picture. If I plot the point 0, 1, which is like here, 0, 1, how far from the origin am I? 1, and what is this angle like that? 90 degrees. See, you draw the picture, it's so easy. I don't know why the book doesn't teach you that, it's just there. Okay, so how many answers am I gonna have? I'm gonna have 5 answers, okay. So the first answer is, you take the fifth root of 1. It's 1. See, that's not interesting to me. I want to put 32 there. At least fifth root of 32 is 2, right? It's a little more interesting. And then you have to divide the angle by 5. What is 90 divided by 5? 18. See, this one comes out nice, 18 degrees, okay? And there are going to be 5 answers, so what is 360 divided by 5? Cheat? 72. So every answer, all the answers are going to be 72 degrees apart. So once you find the first one, to get the next one, just add 72. And then add another 72. And another. Another. There you go, those are your 5 answers. See, so you really don't need to memorize that ghastly formula. You just gotta know how it works. It's the reverse of de Moivre's theorem. You take the root of that number and you divide it by 5. Whereas de Moivre's theorem, you raise it to that power and you multiply the angle. So this is going the opposite way. You take the root and you divide the angle. Oh boy. Okay, so tonight's homework is the practice test, but we're not having the test till next week, Thursday. Hey, wait. How many of you are taking AP US History tomorrow? Okay, so tomorrow we're just gonna have like a work day in class. Anyway, if we do discuss the practice test, you know what? Wait, time out. I'll have to make an administrative decision here. I want to see something. Maybe I should assign like a review assignment. But that's what the practice test is. What am I afraid of? Like, what if you do the practice test tonight? What if you do the practice test tonight, but the test is not the next Thursday? Are you going to forget everything? So maybe we should just do a review assignment. Yes or no? You don't even know what I'm talking about. Or, since you have, wait, am I seeing you tomorrow?
Yeah.
Oh, I was gonna say, since you have junior prom, then maybe I should make, homework.
Yeah.
Oh, never forget that then. You guys should have just played along. Yeah, it's on Saturday, Mr. Park. It'd be nice.
Next week, no homework next week.
We don't even
Let me think.
we don't even see one.
Oh, unless we just break up the practice test into little chunks then.
Or maybe, I don't know if we do.
Okay, let's do that then, Wait, I came up with an even better idea.
Did you want us to present the plan?
Would you rather have no homework tonight or no homework tomorrow? Okay. Oh yeah, Mr. Park, I wasn't gonna do it anyway. That's what some of you are thinking, huh?
Maybe
Yeah.
that's true.
Yeah, okay. Where's the trig? Okay, that's the assignment. Okay, let's revise the homework then. Oh, I hate that. I really hate that. Okay, look at the practice test. So let's just break it up into little chunks. Now, I just want to let you know the practice test, look, it's 5 pages long here. Oh my gosh. That's because I couldn't figure out how to put that polar graph paper like on 2 sides. That's why it came out long. So that's why it's like, you know what I mean? So that's the only reason. It's not like it's like, it should have been only 4 pages. Okay, so tonight's homework, how about we just do 1 through 4 then? Break it up into chunks. So you guys understand? 1 through 4 only. That's like 1/3 of the test. We'll do a third, and a third. How's that? Okay? All right, we are done then. So this class ends at 9:10. You got 15 minutes left. So if you're listening on the video, the homework is 1 through 4 on the practice test. Plus got all the solutions on there as well.
Can I go print out the practice stuff?
Yes.